Hello and welcome everyone to the Mr. Lubis Math Channel. Hope you guys are doing well today. We are going to be looking at section 3, starting chapter 3.311, and we're investigating exponential functions, in this case specifically y equals b to the x. Again, b is your multiplier because that's what's raised to the x power. So we're going to look and see how does our multiplier affect the graph. So the first graph we're going to look at is y equals 1/2 to the x. For right now, I want you to try and do this without a calculator. And we're going to do -2, -1, 0, 1, and 2. And I'll come back to the negative exponents, so I'll start with 0. Remember, anything to the 0 power is 1. So 1/2 to the 0 is 1. 1/2 to the first power is, anything to the first is itself, so we'd have 1/2. And then 1/2 to the second means you have to square the top and square the bottom, so that would be 1/4. As we go to the negative exponents, remember, to make a negative exponent positive, you must flip the base. So 1/2 to the negative first is the same as 2. I flip that, and then the exponent becomes positive. So the same as 2 to the first, which is just 2. And then 1/2 to the negative second is the same as flip the base, get 2, make that exponent positive, same as 2 squared, which is 4. If we go ahead and plot these 5 points in, I'd have -2, 4 up here, -1, 2, 0, 1, 1, 1/2, and 2, 1/4. And so I'd have something that looks like this. And remember, we can never touch the x-axis. And so our domain, it would go left forever, because again, as it's going up, it is going left, and it would go to the right forever. So from -infinity to infinity, or you can write all real numbers. Our range, remember, we don't ever touch the y-axis or the x-axis. So we get really, really, really close to 0. So I put a 0, but don't touch it. So I have the parenthesis, not the bracket, meaning it's not equal to, and then it goes up forever to infinity. As we go on to number 2, or the second one, y equals 2 to the x, same idea. We're going to go from -2 to 2 x values, and 0, anything to 0 is still 1. 2 to the first is 2. 2 to the second is 4. Again, going back with the negative exponents, if I do 2 to the negative first, I'd have to flip 2, so I get 1/2, and then that exponent becomes positive, 1/2 to the first, which is just 1/2. And then 2 to the negative second, again, I flip my base to get 1/2, and then my exponent becomes positive. 1/2 squared is 1/4. So now we have that table. If you notice, the table is just kind of in reverse. So now I have -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. And again, we would have our domain of x equals all real numbers, or -infinity to infinity. And our range, it goes down and gets really close to 0 again, but never touches it, and goes up for infinity. Alrighty, so same thing here, -2, -1, 0, 1, 2. All right, so as we look at the next group where I have a multiplier or b value of 1/3, notice again it is decreasing. And our domain is still all real numbers. Our range is still 0 is less than y, which is less than infinity. And then as I go to a b value of 3 or a multiplier of 3, again, it's increasing now. It is just increasing faster than the 2 to the x we had before. Our domain is still all real numbers, and our range is still 0 is less than y, which is less than infinity. So go ahead and take a moment and state a few things that you can draw conclusions-wise about these exponential functions. As we go to the back is a little tricky, and you may use your calculator for the back now. And for the back, number 1, y equals 1 to the x. I'll just get you started with a couple of these. 1 to the x, remember, 1 times itself any times, is still going to be 1. So if we did -2, -1, 0, 1, 2, 1 to the 0 is still 1, 1 to the first is 1, 1 to the second is 1. They're all 1s. So what this would be, it would just be a horizontal line going through all the 1s. I want you to state the domain and range. For 0 to the x, that gets a little tricky, because our negative exponents, well, let's go 0 to the 0. Anything to the 0 power is going to be an error here. And if we actually type this in, 0 to the x, when we look at our table, we see that anything from 0 below is an error. And anything above 1 is 0. So the reason the negative exponents are becoming errors is if you think about 0, there's really a 1 underneath the 0. And when you have a negative exponent, remember you have to flip that fraction to make it positive. So I get 1 over 0 now squared. And that would be 1 over 0. And remember, 0, anything to the 0 power is anytime 0 is in the denominator is undefined. So what we'd have here is we have an open dot at 0, 0, because it's not equal at 0. It's an error at 0, but as soon as we get right past 0, like 0.1 or 0.01, everything else is equaling 0. So we'd have just a line right like that with an open dot. Again, state your domain and range. For 2, now we have negative b values. And what's happening with these negative b values, it's a little tricky, is you're going to type these in. Make sure the -2 is in parentheses. And then you raise that to the x power. Now when you make the table for that, notice how it's going from positive 0.25 to a negative 0.5 to a positive 1 to a -2 to a positive 4. So it's constantly, every x value is constantly going back and forth between negatives and positives. And if you actually looked at the graph here, nothing shows up because of that going back and forth. If you want to see the graph, you can press zoom and then decimal, number 4, and you get an idea what it looks like. See how it's going back and forth? And it does look like an exponential increasing, but then we also have the mirror image points of it below the x-axis as well. So if we go to graph this, we'd have -2.25, -1, -0.5, 0, 1, 1, -2, and 2, 4. Go ahead and try the -1/2 to the x. See what you get for that. So here's what we have. Again, and if you look at the Zoom decimal version of it, you see that it looks like an exponential decreasing. But again, since the base is negative, the y values are going from negative to positive back and forth. So that's what's going on with the graph here. And again, it looks like an exponential decrease. However, that back and forth is making the graph a little crazy. So the one thing that we're going to say is true for all exponential functions. For exponential functions, the multiplier b must be greater than 0. B must be greater than 0. Because once it equaled 0, that's when the crazy things happened. We had all those errors here, and we had the back and forth when they were negatives. And the other thing we should kind of know as well is that if our b value is greater than 1, like when our b was 2 and 3, notice how it's increasing. So if your b is greater than 1 or your multiplier is greater than 1, graph increases. If your graph is, or your multiplier is between 0 and 1, so again, notice not equals 0, not equals 1, because when it's equal to 0, it's the error, and when it's equal to 1, it's just a horizontal line here. Then your graph decreases. All right, I hope you enjoyed these exponential functions.